Hey guys, Mr. Backenberg here. In this video, we're going to take a look at domain and range. When we're looking at finding the domain of a function, we're more so concerned about things that we're not allowed to do, mathematically speaking, than we are with things that we are allowed to do. So there's going to be two key things that we're going to be on the lookout for. One of them is dealing with fractions. And with fractions, you're never allowed to have 0 on the bottom of a fraction. So anytime we have a fractional function, we're going to work on making sure that the denominator is never 0. The other thing we're going to look at is with square roots. And when you're dealing with square roots, you're never allowed to square root negative numbers. So those are going to be the two things that we're going to be on the lookout for as we work on restricting down the domain of a function. So in this first example, we're going to look at finding the domain of a function, and the function I'm going to give you is f of x equals the square root of x plus 3. Now here we've got a radical, a square root, and we just got done saying that we're never allowed to square root negative numbers. So we need to make sure that the stuff underneath the radical is never going to be negative. So what we're going to do is we're actually going to write out an inequality. If the stuff underneath a radical is never going to be negative, then here's what needs to be true. The x plus 3 that's underneath the radical, well, if it's never negative, then it needs to be greater than or equal to 0. And now what we're going to do is solve this inequality to get x alone. So to get rid of the plus 3, we're going to subtract the 3 over to the other side. So we're going to get x is greater than or equal to negative 3. So this is actually going to be the domain of our function, meaning that it's safe for us to plug in any x value as long as it's greater than or equal to negative 3, because then we're never going to get negative numbers underneath the radical. Now we can also take this inequality and we can write it out in interval notation. So when we're writing out an interval, remember we always start at the smallest value. So if we're looking at things that are greater than or equal to negative 3, then negative 3 would be the smallest value in our interval. It does get included since our inequality has the equals to line underneath it, so the negative 3 is going to get a square bracket around it. And then here we're looking at all of the values that are bigger than negative 3, and there's really no stopping point to those values, so our interval is going to run out to positive infinity, and infinities always get a parenthesis around them since they're not included. Now I said there was another issue that we could run into, so I'm going to give you a new function here. So we've got g of x equals 7 over x minus 5. And here, since we're dealing with a fraction, what we need to make sure is that the denominator is never 0. So we're going to write out another inequality here. And here's what we want. We want the denominator, so the x minus 5. We don't want it to be 0. So I'm going to write out an inequality that says that this cannot equal 0. And then just like we did before, all we're going to do is solve to get x alone. So I'm going to take this minus 5 here, and I'm going to add 5 over to the other side. So x cannot be 5. So by saying that x cannot be 5, we're automatically implying that x can be everything else. So this is going to be our domain here. It's every number except for 5. Now we can also take this and write this in interval notation. If we think about writing out an interval, we're thinking about starting with the smallest value. And here there is no smallest value, so we're going to start at negative infinity. And then we're going to go until we hit a stopping point. We're going to stop at 5 because 5 is not included in the domain of this function. But we can have values that are bigger than 5. So we actually need to open up another interval in here and start this one at 5, not included. And we could have any number that's bigger than 5. So that's going to run out to positive infinity. And to show that it could be in this first interval or in this second interval, we put a union symbol between them. And that just looks like a U. So this inequality, x cannot equal 5, and this interval are both saying the same thing. It's saying that we could have any number to plug in for our x except for 5. 5's not going to work because then we would get 0 on the bottom of our fraction. Now sometimes when we're dealing with more complicated functions, we have to be extra careful. So I'm throwing a new function at you, h of x, and there's going to be a fraction in here. On the top, we're going to have the square root of x, and on the bottom, we're going to have x minus 3. Well, here we've got both of our issues. On the top, we've got a square root to worry about, and on the bottom, we've got a fraction to worry about. Let's look at that square root first. We need to make sure that the stuff underneath the radical, underneath the square root symbol, is never going to be negative. So in this case, x has to be greater than or equal to 0. But we also need to worry about that stuff happening on the bottom. So we need to make sure the x minus 3 is not equal to 0. So here, if we add that 3 over to the other side, we need to make sure that x is not 3. So when we're writing out the answer here as far as the domain goes, we need to be careful about both of these things. We need to make sure that our x values are greater than or equal to 0, but x cannot include 3 there, because as soon as we try to plug in 3, we're going to get 0 on the bottom of the fraction. Now when we're writing this out in interval notation, we need to start with the smallest value. So as we're looking at these, we need to make sure that our x's are greater than or equal to 0. So my first interval is going to start at 0, and it's going to be included. And we're going to run until we hit a value that we have a problem with. And we have a problem at 3 here. So 3 is going to close that interval, but it's not going to be included. Now we need to open up another interval because there are numbers bigger than 3 that we can use. So we're going to start at 3 again, but not included. And this is going to run out to positive infinity because we need all those things that are greater than 0, but not 3. So out to infinity, and again, we're going to use that union notation since we're joining these two intervals together. So it's everything from 0 up to 3, but not included, and then from 3 all the way out to infinity. Now in this example, we're going to look at finding the range of a function. So I'm going to give you a function here, so let's look at f of x equals negative x squared plus 4. And the range is talking about the y value answers that we're going to get back when we start plugging in x values. And I think the range is easiest to look at when we've got a graph that we're working with. So we're going to use our calculator to help us out. But in order to use this in our calculator, we need to write it as a y equals equation. And just remember that the f of x means y equals. So we could really just write this as y equals negative x squared plus 4. And then I'm going to go to my calculator. So on my calculator, I've already gone to the y equals screen and I've typed in my equation, the negative x squared plus 4. So I'm going to graph that out. Now, as we're looking at this graph, we're talking about the range, so we're talking about the y values that show up on our graph. Now, we should know that since we're dealing with an x squared function, it's going to have a graph that's a parabola. And we've got that negative out in front, so that's going to flip our parabola over so it's facing downward. So we end up with a picture that looks like this, and we're trying to figure out what y values show up as part of the graph. Now, our calculator doesn't do a good job of putting arrows on the end here, but we should know that our parabola is going to keep extending downward. But as we come up, it looks like the highest we go on here is a y value of 4. So there's really no bound as far as how low our graph is going, but our graph stops at 4. So we can actually write this range out in interval notation as well. We said there was no bound to how low our graph was going to go, so our interval is going to start at negative infinity, and then the highest value that showed up on our graph was 4, and 4 is going to get included since we did have a point up there at 4. That's going to be it for this video. Thanks for watching.